Okay, today you're starting chapter 6. You should have gotten a green packet, and that's what you'd be filling out for this. You don't need to take any other notes besides just filling out your green packet today. So, part of chapter 6 that we're doing is all in transformations. And a transformation is just a manipulation of a shape. So, manipulation of a shape. All it means is that the shape is changing. So it might get bigger, it might get smaller, it might turn, it might flip over, it might just do all these different kinds of things. So if you have a shape and you somehow change it without actually like changing what the shape was, like a triangle to a circle wouldn't count. If it's a triangle and it stays a triangle, that's some sort of transformation there. You pause until everybody's written that down. Okay, so image, we're not going to fill it today, we'll fill it out a different day. A reflection is when you move something over the same distance that it started as. So let me just draw you a little picture here. So for example, let's say you draw a line. Okay, and if you drew a point, a reflection would just be moving at the same distance it is from that line to the other side of the line. So it's like reflecting over a line. So if you like to fold this point over to that side of the line, it would land right there. So if you think about like a mirror and like how it's like staring back at you, if you fold it over and it lands on itself, that's a reflection. So same distance from one side to another. Please pause until you've written that down. Okay, so you're going to be doing two types of reflections today, reflection over x-axis, reflection over a y-axis. So, reflection over x-axis, you draw a coordinate plane here, would be reflecting over the x-axis. So, this is your x-axis. So, if anything is on the bottom here, it's just going to end up on the top. So, it's just folding things over from one side to the other. So, if it's on the top, it'll end up on the bottom. If it's on the bottom, it'll end up on the top. So if I were to draw a little point in there, if it was up here, if you reflected over that line, you just put it down here. Okay, so it's the same distance away from this line from there to there as it is from here to here. Okay, reflection over the y-axis, if you would draw it, would mean things are going over the y-axis, so they're going over this line. So if something started over here, it will move over there. So if the point was here, it'll go here. So it'll go left to right or right to left. Please pause until you have that ready. So what you're going to be doing in your worksheet today is you're going to be reflecting over things. So sometimes it'll be x-axis, sometimes it'll be y-axis. You just have to read to make sure you know what you're doing. So this one says x-axis. What you're going to do is reflect this point over the x-axis. So the x-axis is this line. So what you're going to do is you're going to count away how far that point is from that line. So if you look at that point, it is 1, 2 away from the x-axis. So since you're reflecting it over the x-axis, you're going to go 1, 2 to the other side. So 1, 2, and then you draw your new point. Okay, so you're just moving it over that line. And the coordinates of your new point now would be 3, negative 2. Okay, same thing with this one. This one happens to be 2 over the x-axis from the bottom. So now we're going to go 2 over the x-axis to the top. Coordinates of that one would be negative 7, 2. Remember when we do coordinates, first number is left and right, second number is up and down. So since we're over the y-axis is this line right here. So you're going to count them far away from that line. So it goes 1, 2, 3, 4 away from that line. So you go 1, 2, 3, 4 away from that line. So it's just flipping from one side to the other. Make sure you know what axis you're flipping over. That's the most important part. So our new coordinates of this one would be right 4, up 3. Okay, we'll do one more of these. So over the y-axis, so again, it's over this line. We're going to count how far it is from that line. So it goes 1, 2, 3, 4, 5. So we're going to go 1, 2, 3, 4, 5. So the coordinates here would be -5, -3. Okay? So your worksheet will be pretty simple as far as that goes. It will give you a point, and then it'll tell you to flip it either the x-axis or the y-axis. So you just need to count how far it is from that line, then just move it to the other side of that line the same distance away. Okay, you're also going to be talking about symmetry today. So line of symmetry is a line that is basically in the middle, so both sides are the same. So line that divides an object into equal parts, we'll say. Don't judge my handwriting. So a line of symmetry, for example, if we had a square, a line of symmetry in this case might be one right down the middle. Okay, right, because the stuff that's on the left side is the same as the stuff that's on the right side. So I think on the back of your worksheet, one of the things you're doing is drawing lines of symmetry. Sometimes lines of symmetry, there's more than one. Sometimes there's only one, sometimes there's none. So if you look at this square, we can see a line of symmetry. One example would be, let's see here, right down the middle. Oops. Well, that didn't work. Let me just draw. Okay, right down the middle here. Okay, if you were to fold it over that side, it would land on itself. Another one would be across the middle this way. In this case, we actually have two more. Going across the diagonal like this would work. Or you can kind of see if you were to fold it over, this whole corner would land right on that whole corner. And the other one we're looking at here is this one. So part of your worksheet will just have you drawing lines of symmetry. Draw as many as you can. Another one here, this triangle. So you can see this is not a line of symmetry. This, not a line of symmetry, right? If you were to fold over that line, it would not land on itself. Something like this is, right? If you were to fold this corner over this line, it would land right on this corner over here. Okay, a circle's kind of tricky because you can see we have one here, 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 etc. Right? So many lines of symmetry that you can't even draw them all. So when you have something like a circle, which this is really the only example, you have an infinite number of lines of symmetry. Infinite just means they go on forever and ever and you can't even count them. There's so many. Okay, one with a rectangle. One down vertically would be one horizontally. And in this case, it actually wouldn't be diagonally. And if I was there, I would show you an example that this corner would only actually end up like down here. If you have a piece of paper, you can try folding it over the diagonal and seeing if that works out. All right, so your reflection of axis is symmetry worksheet. So on the front, you're reflecting points over the x and y axis. On the back, one of the things you're doing is you're drawing lines of symmetry, and the other one, it has a line of symmetry, and you just need to say if the one is it or not. So for example, if I gave you a square and I drew a line like this, is that a line of symmetry? No. So you'd write no. Where if I gave you a square and I gave you line of symmetry like this, you'd probably write yes. Okay? You are going to have a vocab quiz this Friday. I'll get you the words on Wednesday. You have no IXL this week. But if you didn't finish last week's B7 and E5, you have today yet to finish those. Tonight I will be adding people to ICU that are still not done with them. Okay, I hope you have a good rest of your day. If you have any questions, please feel free to message me on Schoology or Remind. The sub and Mrs. Hess will be walking around and correcting your worksheet. Please let me know if you need any help. See ya.